Hello, everyone. My name is Aruho Prisla, and I'll be taking us through machine learning. So, machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. In simple terms, the machine is just given data so that it recognizes patterns and automates the program instead of manually adding the data. We have two types of machine learning, which is supervised machine learning that works with labeled data and unsupervised machine learning that works with unlabeled data. The applications of machine learning would be image recognition, spam detection, and recommendations. With image recognition, because we have to identify um, like the the patterns on an image to relate it to particular information. Then spam detection that recognizes if information is being sent, like the same information is being sent multiple times. Then we look at the deterministic models uh, that work with no randomness and probabilistic models that work with randomness. Then why machine learning, or reason as to why we use machine learning. It automates database decisions, handles complex patterns beyond human programming, uh, things that require a lot of data that cannot be comprehended by humans. Then applications, it can be applied in health, applications in finance, in healthcare, in marketing, and autonomous systems. Then we look at regression. So regression models are used to represent the relationship between one dependent variable and explanatory variable, like basically to compare two things. So regression steps will include hypothesized deterministic components, that is to do with assuming, specify probability distribution random error term, evaluate the fitted model, use model for prediction and estimation. These are from the Allison Diploma course. That's our source. Then linear regression and logistic regression. Linear regression, the relationship between variables is a linear function. Uh, then logistic regression is used for binary classification problems, which would include things like yes or no, or true or false. Then we look at the parametric model and the non-parametric model. The parametric model is a model to fit to the data is always known. Then the non-parametric model, the data tells you what the regression should look like. Then we look at the iris dataset. The attributes for the iris dataset would be the sepal length in centimeters, sepal width in centimeters, petal length in centimeters, and petal width in centimeters. They're basically supposed to identify how a flower would appear. Then we move to k-nearest neighbor, or KNN. The main KNN algorithm steps would include calculating the distance between all the training data and the test point, finding the nearest k neighbors by sorting these pairwise distances, and classifying the point based on a majority vote. The applications of KNN: text mining, agriculture, finance, and cargo competitions. The pros of KNN, or the advantages of using KNN: it is easy to explain, simple to understand, and extremely powerful. It doesn't require any assumptions on data distribution. You can use it for both regression and classification problems. You can use it easily with multi-class datasets. Then the cons or the disadvantages of using KNN, the efficiency of the algorithm declines very fast as the dataset grows, meaning as you keep pumping things into the algorithm, its efficiency keeps decreasing. It comes at a cost of making the prediction step relatively expensive. Every time a prediction is to be made, it searches for the nearest neighbor in the complete training set. It suffers from skewed class distributions, meaning if a specific class frequently occurs in the training set, then it is most likely to dominate the majority voting of the new example. It cannot work if there are any missing values. Then on to the Gini impurity. It measures the frequency at which any element of the dataset will be mislabeled randomly. So the Gini index has values inside the interval 0 and 0.5, whereas the interval of the entropy is 0 and 1. Entropy is more complex since it makes use of logs, so the calculation of the Gini index will be faster. Then on to information gain. Bias for the attribute with many outcomes. It means it prefers the attribute with a larger number of distinct values. Then on to decision trees. Here we discuss the pros and cons of decision trees. With pros, we have they're easy to interpret and visualize, have no assumptions about distribution because of the non-parametric nature, and can easily capture nonlinear patterns. Requires few data pre-processing from the user and can be used for feature engineering. Then the cons would be sensitive to noisy data. The small variation in data can result in different decision trees. Biased with imbalanced dataset, therefore it is recommended to balance out the dataset before creating the decision tree. Then we move to ensemble learning, which is about combining many mediocre or weak models in one supermodel. Under ensemble learning, we talk about bagging and boosting. Bagging involves creating different models using different bootstrapped training sets and average their predictions to produce the final output of the model. Boosting is a sequential tree growing with weighted samples. Then we talk about random forest. A random forest is a slightly modified bagging algorithm. It's a collection of decorrelated decision trees for every tree. And for every tree, we subsample the examples with replacement bootstrapping. For each subsample, we choose attributes at random. We randomly pick features in each split. We build the tree only on these random features and with the current subsample. So we also have pros and cons of random forest. The pros will include robust to outliers. It works well with nonlinear data. It lowers the risk of overfitting, runs efficiently on a large data set. Cons of random forest: biased while dealing with categorical variables, slow training, not suitable for linear methods with a lot of sparse features. Greedy algorithms do not yield the global optimum tree structure. Then we talk about the principal component analysis. The goal of PCA is to reduce the dimensionality of the data while keeping the information loss to a minimum. We apply PCA in image compression, pre-processing step for classification, regression, clustering tasks, and then facial recognition and data visualization. So we will also discuss a real-life problem that can be solved using machine learning. And in my case, I'm going to be talking about self-driving cars. In this case, what is the problem? The problem is cars have to detect roads, pedestrians, traffic signs without a human being behind the wheel. And why is it a problem? Drivers make mistakes that cause accidents, human error, Roads are dynamic and unpredictable. You will not know at what time you will be you'll be facing a car, you'll be colliding with a car. Many cars will be moving at the same time, so some things are not debatable. And then, to whom is the problem? Who are the people facing this problem? The drivers and passengers. Basically, it is the road users or people that actually use cars, or the people that are going to be affected if this car is to be out of control. The drivers and passengers, the pedestrians, healthcare transport systems, we've seen ambulances, then car manufacturing companies, the companies that are actually supposed to come up with the ideas for these manufacturing of these self-driving cars. Then, to what extent has the problem gone? According to Google, annual road accidents exceed 1 million worldwide. 90% of these accidents are because of human mistakes, and others are due to traffic congestion and crashes. How is this a problem? It requires real-time object detection and classification, mostly to avoid collisions, needs instant braking, steering, and acceleration. In this case, when you detect an object in your path, it needs to have an instant braking, or when the object is off, it needs to have an instant acceleration. Must process large sensor data, and errors can result in serious accidents. Should the self-driving car system be designed with an error, that means that all these above problems, the object detection won't be happening. So you'll find yourself experiencing even more accidents than we were experiencing before. Thank you. Have a lovely day.